Okay, we are on to the 10th lecture. So it's been some time since I put one up. I've had problems with my camera or camcorder. This lecture is going to be on Pythagoras. This is the 10th lecture, and I remind you that if you haven't seen the first 7 or 8, you should really have a look at those first. But I'm going to repeat things anyway in this lecture to help those who just want to get into Pythagoras. There is an interesting story about Pythagoras, which you can sure find on YouTube and various other places. The myth and the facts. It's difficult to know exactly about his life, but he's a very interesting character, and it's recommended to look into him. Apparently the first philosopher, and in fact he coined that name. So he is actually known amongst us more lowly caste for his mathematical theorem on triangles, and that is called the Pythagoras Theorem. It is known by any kid that goes to school, high school. They'll be taught this theorem, and the task I set myself was to see if there was a connection between his name and theorem. And he is actually part of my book, called Beyond Science, and which I've subtitled sort of as a mathematical proof of the existence of God. And he's one of the 207 inventors, discoverers that are in that book. So let's have a look. He is quite unique in respect to the way I found a connection between his name and his theorem. So let's have a look. It's not quite certain whether he, I'll take that away, whether he actually discovered this theorem, but that doesn't really matter so much. He was known for it and dwelt on it, so even if he didn't discover it, it is very interesting that his name is connected to it, so that might prove that he did discover it. So, Pythagoras Theorem. We're going to have a look at the theorem first of all. A right angled triangle, which is 90 degrees, and this side is called the hypotenuse, and generally speaking they give these size letters. This is length A, and this will be length B, and this will be length C. Doesn't matter if it's centimetres, millimetres, metres or miles, it doesn't really matter. This is just a length. And his theorem said that if you square the two smaller sides, you'll get the square of the hypotenuse, the longer side. And in the geometrical viewing of this, it's like putting a square on here. The area of this and the area of this side will be equal to the area of the square on this side. So you put a square here, square there, and a square there, and this square equals the sum of these two squares, which is a very, it absolutely works for any right angled triangle, doesn't matter which one, but there are a few select triangles which, well, not few, there's an infinite, but in the lower numbers there are ones that people do remember. The most famous right angled triangle with what we call integer numbers is known as the 3, 4, 5 triangle, and that will be a side 3, that will be a side 4, and this will give you a side 5, because 3 squared, which equals 9, 4 squared, which equals 16, and you add those together you get 25, and that equals 5 squared. If you don't know what squares are, it's a number that you multiply by itself. 3 squared is 3 times 3, 4 squared is 4 times 4, 5 squared is 5 times 5. So these numbers give you the 3, 4, 5 triangle. So let's now look at his name, and we'll see some interesting relationships in his name. So P, using the placement value, is 16. It's the 16th letter of the alphabet, and it's worth 16. And that is 4 squared. Y is the 25th letter, worth 25, and is 5 squared. So straight away we've got 4 squared, 5 squared in his name. And if we now look at Thag, Thag is 20, T is 20, H is 8, A is 1, and G is 7, and that will give you 36. So now we've got 6 squares. 6 times 6 is 36. So we've got a few squares there. We're going to look at Horace now. That's the last part of his name. And Horace, we're going to do differently. We're going to use the sum of squares. Just like we use the sum of squares for his theorem, a squared plus b squared, the sum of squares. But we're going to square all of Horace. We're going to put O-R-A-S. Now we're going to put the placement values because O is the 15th, R is the 18th, A is the 1st, and S is the 19th. 15, 18, 1 and 19. We're going to square those. So 15 squared is 225. 18 squared is 324. 1 squared is 1. And 19 squared is 361. If we add those together, I get 5 and 4 is 9 plus 1 is 10 plus 1 is 11. 2 and 2 is 4 plus 6 is 10 plus 1 is 11. I missed out something. Right, hold on a moment. Made a mistake. Oh no, it's not Horace. It is not Horace, it's Horace. I've got to add A. Yeah, I made the mistake before. So there's another one there. We're doing, did it wrong. Pythagoras. Pythagoras. Oh, I did it wrong. Pythagoras. Here we are. I'm going to wipe this out. So we're going to do the last part of his name, Pythagoras. That's 1 and that's 7. G is 7, A is 1. Thought it was going wrong. 1 and 49. 7 squared is 49. 1 is right. So I'm going to do that all over again. Right, so we've got 1 there. 1 and 9 is 10. 5 and 4 is 9 plus 1 is 10. It's 21, so carry 2. 4, 5, 6, 7, 8 plus 6 is 14, 15, 16. And then I've got 2 plus 3 is 5, plus 3 is 8, plus 1 is 9. Okay, so we're doing not Horace but Pythagoras. Pythagoras gives you 961 when we add the sum of the squares. And 961 is 31 squared. So we've got another square hidden in his name. So, next stage. I'm going to go fairly quick because there's quite a lot to cover in this subject, Pythagoras. So we've connected the name to squares, to sum of squares or to squares. The question now, what about some of the other parts of that triangle? There's a side, there is a hypotenuse. So we're going to look at some other aspects. If we now take, you've got to follow this perfectly, we're going to look at pi. Let's get Pythagoras over here. P-Y, pi. P we had, I'm just going to do it this way. P we had was 16 and 25 is 41. If we then take the large value is that 16, P is 16 and 16 equals 96 and Y is 25 and the word 25 equals 149. If I add those together I will get 15, 14 and 2. 245 is the large value, okay? And if you're not quite sure what all these are, then do check back on my other videos. I've still got to explain what these all really mean, which is going to have to wait a little bit longer. But you're getting an idea if you're looking at these that these are significant. They do show connections, and the question is, well, why are there 4? Maybe there's more than 4, right? But why particularly these 4? So the normal inner values we said were like this. You take P, the normal value was P was 70. Why is it 70? Because it goes up in tens. You get to A is 1, B is 2, up to I is 9, J is 10, then it goes up to K is 20, 30, 40, all the way up. You get to P is 70. That's just like in the Hebrew and Greek gematria. And Y comes out to be 700. So altogether we get 770, which we'll look at this number in another slideshow. The significance will come out when I talk about the pyramid, the Great Pyramid, and why the cap is missing. Particularly that represents pi. But the normal inner value, this is the normal value, NV. We take now the normal inner values. I do the same thing for the large value. We take 70 and 70 equals 110 and 700 is 139 and that gives me 249. That gives me the normal inner values. Okay, now wipe that off. So I've got these 3 values which I now add together and I'll get 15. 4 and 4 and 4 is 12, 13, 2, 4, 5. I get 535. What is the significance of that is that if you take the word squared and you find the normal inner value, the normal inner value is 535. So we see a connection between pi and squared. Okay, next we're going to look at Thag. Now Thag, Pythag, I'll put his name back up here. Pythag, remember we had Thag was 36, Pythagoras. Now Thag, T-H-A-G, Thag has a large value of 255, and he has a normal inner value of 280. You'll have to check these out if you don't believe me. And if I add those together, I get 535. So I've got now a connection between pi and Thag. It's like two sides of the triangle P and Y equal the hypotenuse Thag. Well, we'll see that actually pi is also connected to the hypotenuse later on. So, but we've connected all two of these, pi and Thag, to squared. So, next we're going to look at Thag again. Thag has a placement value. I'll take that away. Of 28. We had this 36 before. That was the placement value, PV, and it was 6 squared. So that's Thag. And it also has a normal value of 216. NV. Why is it normal? 200. T is 200. H is 8. A is 1. And G is 7. That's 18 is 16. It's 216. If I add those together, I get 6 and 6 is 12. 3, 4, 5. I get 252. We're going to look at this number some other time when we discuss the word truth. In Hebrew, the word emet is connected to 252. So, I'm going to wipe this off now, and we're going to just look at Thag. Strange word, Thag. Now, okay, we have 252, and we're going to look at the word side. The word side has a normal inner value of 252. Side S is 100, 100 is 108, I is 9, 9 is 42, D is 4, 4 is 60, E is 5, 5 is 42, 8, 9, 10, 11, 12, carry 1, 4 plus 6 is 10, plus 4 is 14, 1 is 15, carry 1 and 1 and 1 is 2. So we see that the normal inner value of the word side is 252, which equals Thag. So Thag is a side. And now, just a sort of continuance of that is an interesting relationship, because what we've got here is 216. And 216 is 6 times 6 times 6. In other words, it's 6 cubed. So we've got here 36, which is 6 squared, and we've got 216, which is 6 cubed. So we need to add 6, because then we'll have 6, which is 6 to the power of 1, plus 6 squared, 6 to the power of 2, plus 6 cubed, 6 to the power of 3, and that will give me 258. Getting a bit cramped here, take him away. So we've got 258, and that is the large value of Oras. That's up there. Oras, so 258, that's the large value of Oras. So we've got another connection, and with this number 6, which is another lecture. We'll talk about the number 6, 666, that's a very interesting topic. I was talking to a friend this afternoon about it. So, another interesting connection with his name and the theorem. So we've had side, we've had squared. Now we have to take the squares and we have to sum them. So what we have now is a connection between the word sum, which is, change the colour, sum, which is 53, that's the placement value. That's 19 plus 21 is 40, plus 13 is 53. And we have the word oros. And that's the command to do with the other ones. Right, Pythagoras, or with this, we sum it, we add it together. That's 15 and 18 is 33, 34, 44, 44, 53. Right, check that out. 19 and 1 is 20, 18 is 38, plus 15 is 53. So we've got a connection between sum and oros. So his name really does tell us how to do this theorem. Okay, we had pi was actually 770, okay, and just connected with this idea of side, an interesting gematria comes out with the word side. Side, placement value is 37, that's the PV, and it has a large value of 230. 230, large value. And it has a normal value of 118. Normal value is 100 plus 9 plus 4 plus 5 is 118. Okay? That's 4 and 5 is 8 is 9 and 9 is 18 and 100. 118, add those together, I get 7 and 8 is 15, 3, 6, 7, 8, and another 3, I get 385. But you've got to remember that you get two sides and you have to add them. So you got one side here, and you got one side here, squared, and you add them together. Now if I double that, because of two sides, I get 700 and, oops, I'm going to put a times 2 there, double it, I get 770. In other words, I get pi. So pi is connected to two sides, P and Y. Okay, that covers one side. I've got about 10 to go. No, not really. We are on to more complicated, gets intense. So we're going to look a little bit more deeper. We're going to look at the hypotenuse. It's a very interesting word. I don't know where it comes from. I have to look up this, obviously, Greek, Latin, hypotenuse. It is the side, the longest side, which is opposite the right angle, which we've still got to look at that as well. So, now, we've looked at P and Y, 16 and 25, their placement values. And we've seen that they are square numbers. But why don't we square those numbers itself? So we're going to square 16, which is 256. And we're going to square 25, which is 625, and add them together. We get 6 and 5 is 11, 5, 6, 7, 8, and 8. We get 881. Now, if we take 16 squared, getting caught up here, if we take 16 squared, which is what that is, and we work out what 16 squared is, that means I'm going to work out 16 squared. Now you'll see this in various of my books, and it seems to have quite a number of connections I've discovered by using this. 16 squared, the word squared, the placement value is 85, and 16 is 96. So if I add those together, I get a total of 181. So in other words, I'm taking the word 16 squared and I'm working its placement value out. So I'm going to stick that up there. And I'm going to do the same thing with 25 squared. And if I do that, 25 squared gives me 254. And if I add those together, I get 5, I get 13, and I get 4. I get 435. Do I? It says not. Why is it not? Because I've copied it out wrong. It's not 254, it's 234. So that gives me something like that's 5, gives me 1. Okay, so it's 150. Yeah, can't read my own writing. So we've got the word 16 squared is 181, 25 squares, the word is 234, and I've added them together. Now I'm going to add these two together, and I get 6, I get 9, and I get a 2, and I get a 1. I get 1,296 when I add those together. Now 1,296 happens to be, all by chance, 36 squared. If you square 36 times 36, you get 1,296. But that's not the only interesting thing about that, because besides the fact that we're adding two sides, you know, in terms of the first two letters of his name, which are the two square numbers, 16 and 25, beside that we're going to show a connection with hypotenuse. Because if you take the word hypotenuse, I'm going to have to spell this right, hypotenuse, no, it's an E at the end. Okay, hypotenuse. If I take that word and I work up the large value, the LV value, I will get 1,296. Isn't that interesting? No, it's not right. You'll get, sorry, I will get, can't read, I'll get 881. Okay, that's that one there. In other words, I've got a connection now with pi and hypotenuse. The large value of hypotenuse is 881. Where did I get this idea of 1,296 comes in? Yes, I'll show you now. It gets complicated. So follow me carefully here, because we're going to go back to Pythagoras. I need a bigger board. I'm going to take this away. So, I'm going to go back to Pythagoras, and we're going to look at P and Y again. And we had that was 16, and that was 25, and when we add it together I get 41. So the question is, if this represents the hypotenuse, which I've just shown with this number 881, then number 41 must also be related to the hypotenuse of a triangle, of a integer triangle, and it is the following one. It is a 9, 40, 41 triangle. In other words, if I have a side of 9 and a right angle and a side of 40, so that's the two shorter sides, if I square those, I'll get the square of 41. That follows Pythagoras Theorem. So what we do now is we take, now you've got to remember this number here. Okay, now I'll wipe this off. So we've got the number 9. Now just to prove that to you, by the way, 9 squared is 81. 40 squared equals 1,600. Okay, add that together, I get 1,681. If I work out 41 squared, 41 times 41, 1 times 41 is 41, put a 0 down, 4 times 1 is 4, 4 times 4 is 16, I get 1,681. So this is a right angle triangle. A 9, 40 and 41 is a right angle triangle, with 41 being the hypotenuse which is connected to pi. Okay, so far for that. Now, what I then did is I took the numbers I took the numbers 9, which is that one, and 40, and I wrote down what their placement value is. In other words, the word 9 equals 42, and the word 40 equals 84. Add those together. Add those together, get 6 to 1, 126. Then I took the word 9 and I found out what the normal value of 9 is. N is 50, got two of those is 100, plus 9 plus 5 is 114. So 9 has a normal value. These are placement values. and these are normal values. The normal value of 40 is y is 700 plus 200, 290, 300, that's 900, 990, 1056, 1056. Check myself up. Okay, so that is 40. And I add those two together, and I get 0, 5, 6, 7, 1, 1, 1, 0, 7, 0. So now I've got 9 and 40 the placement value, and 9 and 40 the normal value. If I add those together, I get what I call the total value. I call it TV. Now if I add those together, you can see that I will get 1296, which is 36 squared. Okay, so I've got this connection between pi using the words 16 squared and 25 squared to give me 1296, and I've got the relationship between pi being 41, being the hypotenuse, and the sum of 9 and 40 squared, and I've shown through that we also get 1296. I think that's quite neat, and it just shows how connected this is to something far more complex in the creation of the world than what we perhaps see. In fact, the whole thing is to do with this, but this is a relationship which is all to do with squares. We can't get away from them in Pythagoras. So, is that the end of the story? The answer is not quite. We've got more to go. I just want to show an example, a little bit of a break of an interesting triangle, which is sum of squares. We looked at the three. Let me just rub this off. A 3, 4, 5 triangle. 3, 4, 5. That's the basic of all the integer right angle triangles. But we can have any ratio of these numbers, any multiple of these numbers, will also be obviously a right angle triangle, will be a similar triangle. So for example, I can double each side and I'll get a 6, 8, 10 triangle. So that would also be a right angle triangle. If I multiply by 3, I'll get a 9, 12 and 15 triangle. And that is the one we're going to look at now. Because I was working with King David. And King David and his son was Solomon. So we have two kings of Israel before there was a divide in the kingdom. When the kingdom after King Solomon passed away, so you had the northern kingdom go to Jeroboam and the southern kingdom went to Rehoboam. So, but here are the two kings, and King David, king is 41, connected to pi was 41, and we'll talk about that when we look at the Great Pyramid. David is 40, gives me 81, which is 9 squared. And King Solomon equals 144, which is 12 squared. So we have our triangle here. This is 9, this is 12, and this one was 15. That was 3 times 3, that was 3 times 4, and that was 3 times 5. So my question then was, what is this connected to? In other words, what is 15 squared, which is 225, connected to? If I got 9 squared connected to King David, and I've got 12 squared connected to King Solomon, what is 225 squared? And I thought that it had to have some relationship with the temple, because they were both involved in the building of the temple. King Solomon actually built it, King David provided the materials, he made the plan for it, so he was involved as well, and he was the one that wanted to build it, and God didn't permit him to do so, because he said that his hands were full of blood, because he'd been in the army. So the question is, what is this number 225? And it comes out that the words sanctuary of the Lord, just going to miss out the O because I don't want to put it on the board, Lord because it refers to God, sanctuary of the Lord, if you work at the placement value of that, you'll get 225. So we can see that the hypotenuse of that triangle gives us the sanctuary of the Lord. Now, some of you might say, oh, that's very Masonic. It probably is. Well, I'm not a Freemason, and I'm not a member and nothing like that. But I have studied it, and I do know a little bit about Freemason ideas. And I'm sure the idea of the square and the compass, there are some interesting relationships there, and they might well know this already, but I discovered it. I sort of just decided there must be something interesting about all this. So, we're going to go on a little bit more. We're going to look at the word hypotenuse. The hypotenuse. The hypotenuse. Okay, if I work out the placement value of that, I get 181. Okay, now, funnily enough, just occurred to me that we had that number before somewhere. I know that we had that number. Never mind. I'll come to it sometime. So, we have a number 181. Now, is that part of a right angle triangle? And the answer is yes, because we can draw the hypotenuse with 181 here, and we can put the numbers 19 for this side and 180 for this side. And if I square 19 squared, and I square 180 squared, right, I will get 181 squared. In other words, these two numbers, or these three numbers, fulfill the requirement of hypotenuse, or of Pythagoras Theorem for integer numbered sides. So, now, from that, we are going to look at the squares. I'm not going to go any further than that because it gets rather complicated, and I'm going to leave that bit out. So, we're going to look at the word hypotenuse a little bit more. The word hypotenuse, take out the word the. So, we're going to look at this part of hypo. Hypo equals 8, 25, 16 and 15 is 64. And then we're going to look at enuse. Is also 64, and 64 is 8 squared. In other words, this part of hypotenuse and the end part of the hypotenuse is 8 squared. Now the letter in the middle is a T, and that should ring bells because the T, like a capital T, is a right angle. It represents a right angle. We've got two right angles there. Okay, so we see that the hypotenuse has got like two sides which are squared, and they're connected with this right angle in the middle. So there is an interesting connection between the letter T and the right angle. So, and that connection is as follows. We're going to look at the word perpendicular. The word perpendicular is the word that is when we talk about a line that is perpendicular to another line, it's at right angles. In other words, perpendicular means a right angle, or two right angles. So, if we look at the word perpendicular, so the word perpendicular has a normal value of 727. That's the normal value. Okay, perpendicular is 727. If we now take, I'm going to get lost here, I'm going to zoom. We're going to take the word capital T. We can't use a normal T because that doesn't really give us the form of a right angle. It's the capital T. So we take the word capital T, capital T, and it has the normal value of 500, has a normal value of 514. And then I'm going to well, actually what I wanted was the word the capital T. So the capital T, I have to now add in the word the. The is 213, the normal value. Now I've got 514. And I add that together, I get 727. In other words, the word the capital T has a normal value of 727, which is the same as the normal value of perpendicular, which is a very interesting connection because first of all we're using the same system, and that's what the capital T is, a perpendicular, and it's got in the middle of the hypotenuse. I could go on a few other things, but I'm going to leave it there. I hope you enjoy that one. It is getting complicated, and there are a few other interesting connections, but we'll leave it there. We might talk about the T at some other stage because it has some connections with angles and other things which I don't want to talk about just yet. So that leaves that lecture. The next one I'm going to do, lecture 11, will be on Pascal's triangle, and after that there's plenty more to come. So I hope you enjoy these. Share them please, give me a like, put a comment down below if you want to make any suggestions that you want to hear about anything, any other lectures, topics that you would be interested in, and you never know, might find something on them. Thank you very much for listening.